morning and welcome to our podcast sponsored by Treatment Plant Operator Magazine. My name is Ted Rulseh and I'm the editor of Treatment Plant Operator, which we call TPO. And our topic today is process control strategies, and we're pleased to have with us Ron Trygar, who's the senior training specialist at the University of Florida's TREEO Center in Gainesville, Florida. Ron has a great deal of experience in training wastewater operators. Ron, can you tell us a little bit about your background?
Sure. Good morning, Ted, and good morning, everybody. I started in the field in wastewater treatment in 1983, right out of high school. I was the ripe age of 18 at the time, and of course, I thought I knew everything already about the whole world, so I just jumped in head first, as a lot of people do. And I found that I really enjoyed the wastewater industry and the treatment plant that I was working at because it involved biology and chemistry and it had some math. So I was a little nervous about the math part, but because it's algebra, but I got through that and found that the math made sense, and I got to use my love of biology and biochemistry. So I've been in the field ever since, and I really enjoy wastewater treatment. The idea of biology being used in the process just is fascinating to me. So I've really kind of so I would say that I've gravitated, so to speak, towards the biological treatment processes much more than, say, with drinking water, where drinking water operation might be a little bit more chemistry based. I've found myself gravitating towards the biology side of things. So hence the wastewater operations that I've been in for, like I said, more than 35 years. And in 1998, I became a certified environmental trainer. That's what CET stands for, and the certification comes through an agency now called the Board of Certified Safety Professionals, or BCSP, and the originating agency was called NETA, which is National Environmental Training Association. And the certified environmental trainer was designated as someone who has achieved the top level of licensing in their state, and has also passed an exam given by a board of professionals to show accomplishments, or rather achievement, in training and being an actual trainer of adult learners that are working in the environmental field. So the certified environmental trainer designation really just kind of supports that I am trained in teaching wastewater and water treatment professionals who are usually adult learners, and we need to use some different types of teaching methods and strategies that usually involve hands-on training to reach that audience. And so I have found over the years that being certified as a certified environmental trainer has really helped me with my career in training, and especially with the folks in the industry who are very much hands-on and visual learners. I've been at TREEO Center now for more than 10 years. Started here kind of full time in 2006, and I took a year off and was working for a large county here in Florida, and then ended up gravitating back to the TREEO Center. And TREEO Center stands for Training, Research, Education for Environmental Occupations. So it's an acronym, and the University of Florida is the housing agency of the TREEO Center. And we are in conjunction with the state of Florida DEP and EPA on the water and wastewater side of things. We also do training here for solid waste, which involves landfills and landfill spotters and landfill design and asbestos abatement and asbestos cleanup and hazardous waste cleanup. We do lots of other different training here other than just the water wastewater that I do. We also have a quite extensive backflow and back cross connection control program training that we do here, which is pretty much worldwide renowned right now. We have trainers all around the world that are TREEO representatives, so it's pretty exciting. So
All right, well, thanks for that, Ron. To get to our subject of the day, why do we practice process control in the wastewater industry?
well, Ted, that's a really great question. One of the things I want to point out is we're attempting to use biology and chemistry to treat wastewater to make the water that comes in the treatment plant that's obviously contaminated with human waste and other fun things, and we're attempting to clean that water up and make the water reusable so that it can be used for beneficial purposes or discharged into the environment without causing any kind of environmental harm. So with that in mind, we need to practice process control to maintain the optimum conditions in the treatment plant so that we can constantly meet those requirements. So without process control, without any kind of oversight by an operator or a trained professional to monitor the process would essentially revert back to whatever Mother Nature would like it to be, and it would reach its own equilibrium, and it may not meet the requirements that we have to protect the environment. So process control is actually a very necessary part of maintaining the treatment plant and always maintaining compliance. And our main goal really is to protect the environment and protect human health. So that's it's quite important.
Now, you have an analogy that you've used to having no process control is sort of, you liken that to driving a car. Can you spell that out for us?
Sure. Yeah. I sometimes use in my treatment plant classes an analogy that I came up with a while back, and it really involves the automation side of things with the industry today. And in the practice of using extensive amounts of automation, which is automated sampling, automated testing, and then the results being provided to an operator instead of the operator manually doing things or checking other parts of the treatment plant. So I've kind of likened this method of process control to driving a car using only your rear view mirror as the guideline or a guidance for steering the car as you're traveling forward. So without knowing really what's happening coming into the plant and a little bit better handle on how the facility operates, it's kind of like driving the car using your rear view mirror. So you missed the curve that you should have made a turn and you didn't see something coming, and now you're off the side of the road into a ditch somewhere. So the idea of not really paying attention can get you into trouble, and it's much harder to get the treatment plant back into compliance or operating optimally once it's way out of compliance or in poor operating conditions. So process control really does help us look through the windshield, know what's coming, know what type of environmental conditions might be changing, and making small changes to compensate for those that might otherwise cause us a lot of problems. So when I use that analogy in the class, it's kind of like an aha moment for a lot of the attendees that say, "Oh yeah, I understand what you're saying now. If we don't pay attention, we could be far off the road and not even know it until it's way too late."
Okay. All right. So, what is the role of controlling the biomass population by waste activated sludge flow control? What is the role of that in controlling your process?
Well, Ted, the idea of controlling the process using the waste activated sludge flow rate has been widely known since almost the beginning of the invention of the process, because we've realized that for every pound of BOD or organic load coming into the treatment plant, our bacteria that we're using to do the treatment will reproduce and yield another pound of bacteria for each pound or so of food that's being reduced or oxidized in the process. And each process is a little bit different. Now, I say a pound for a pound. I want to be clear that it's not exactly always that, but there are treatment processes that produce much less yield of bacteria per pound. But the idea really is that the treatment process will produce more bacteria, and the better the treatment plant is working, generally the more bacteria are produced per pound of organics that are being reduced. So the wasting is essentially what I like to call population control. It actually is maintaining the optimum amount of workers, who are the bacteria, the culture of bacteria in the treatment plant, with the amount of food coming into the facility, otherwise known as food to microorganism ratio. And that FM ratio is essentially pounds of BOD loading coming into the facility per day compared to a 1 pound of mixed liquor volatile suspended solids, which we generally say is the bacteria culture. We've kind of said that the volatile solids is the organic portion, so we liken that to be the bacteria. And the wasting of an excess amount of biomass that has grown in the plant allows us to maintain a constant FM ratio, similar to your human body. If you know how many pounds you weigh and how much food you eat per day, and you want to maintain a good healthy diet, then you try to maintain that same amount of food and nutrients and in loading per day, to keep yourself, optimized and keep your health, quality. So that's why we waste sludge to maintain the optimum amount of biomass.
All right, Ron, thank you. You've mentioned that there are three uh, things to be aware of in process control and data, and are meaningful, usable, and relevant. Can you elaborate on each one of those briefly for us?
Sure. Yeah. One of the things that I find as an operator, and I've been in the field for a long time, and I've had a lot of roles in my career. I've been a utility worker all the way up through process control specialist at a large utility in Florida. And one of the things that I can share with the listeners is that we love to gather data, and we love to run samples, and we love to run tests rather on those samples, and come up with the facilities operating numbers. But oftentimes I find that people may miss the mark on the amount of testing they're doing, or maybe missing a certain type of analysis that would be very beneficial rather than just something to do at the facility. A good example is a facility where the operators collect a lot of samples and run all these tests, and then it goes into a file on the computer or in a file cabinet and doesn't really get used. So one of the things that I like to stress in our troubleshooting and consulting and talking with operators around the country is, if you're going to run process control tests, make sure that they're meaningful towards the operation of the facility. Make sure it makes sense to run that test towards, or rather that it could still be used within your process control strategy. A good for instance is, if you don't need to run influent TSS to run your MCRT calculation, then don't run influent TSS all the time. Use what is necessary for the process control strategy, and then make sure it's usable. The data is usable, that you could use it in day-to-day operation. So it's something that is meaningful and it's usable. I can look at this number or this result and say, okay, here's what happened, here's why this occurred. Let's make this adjustment because of these results. And then lastly, relevant. Again, make sure it makes sense to include it in the process control. I've seen a lot of operators. The schedules show that they go out and collect a lot of samples and run tests, and then it ends up not even being used. A good example of that is microscope analysis, where some plants have every single shift doing microscope analysis, and it takes up an hour or so of an operator's time to do it, and then it doesn't really get used in the day-to-day operation. Sometimes we run things a little excessively on one end and then miss the mark on other ends. So those are just three key things that I like to kind of share with the listeners about running process control tests and analyzing your treatment plant operation.
All right. Next, you mentioned two methods of sludge wasting: controlled and uncontrolled. Why are these? Why is it important to understand these?
Wow, that's a really great question, and I'm really glad you brought this up. I learned early in my career that, especially as an operator of small wastewater plants, and when I became I would say, the lead chief operator, I learned that there are two ways that a treatment plant wastes activated sludge. There's what we call the controlled wasting, and the controlled wasting is when an operator will gather some samples and run some analysis, and then plug those results into a calculation to maybe come up with a process strategy, like MCRT or SRT or FM ratio or something to that effect, that they then employ into the actual operation, which means they either increase or decrease the wasting rates, or keep everything the same, make a decision to keep everything the same. There's lots of decision making based off of these results. And that's what we call controlled wasting. So the operator is somewhat in control of the biomass. The second one, which is kind of termed uncontrolled wasting, is where we really don't pay attention to these parameters and just kind of let the plant do its own thing. And I call that letting Mother Nature just run the plant for you. And essentially, bacteria will do whatever bacteria want to do eventually. So if we did not pay attention to the process control parameters, the facility would build up solids, and then eventually the amount of solids that build up would be so great or excessive to the actual clarifier settling ability, or the solids loading capabilities of the clarifiers, and the sludge blankets would build, and then eventually the biomass would just leave that clarifier and go out in the effluent. So when we term solids wasting, or the term solids wasting, kind or rather solids washout, generally means that the facility is experiencing the uncontrolled wasting. There are a couple of tongue-in-cheek words for this that a lot of operators have said. They say it's self-wasting or auto waste, or the plant is sick today. You should have been here yesterday. It looked really great, but today it's not working so good. And that's the kind of operation or process control that basically is just letting the plant do its own thing. When the solids build up to an excessive amount of quantity that the clarifiers can't handle it, the solids will wash out, and it will reach its own equilibrium. Then it will actually look okay for several days after that, because it lost the solids that it did not need, and the facility kind of comes back around again. So what we're trying to do as operators and practicing process control is we're trying to do the first method of sludge wasting, where we're doing the controlled method. I don't want to just take this lightly and say that we don't ever have solids wash out. There are times when influent flows get so great that the plant absolutely cannot handle the flow coming in, and we do experience this from time to time, and plants do get upset because these are biological treatment units. But the idea overall is the operator to practice the controlled wasting, and limit any amount of uncontrolled wasting, where the plant is kind of doing its own thing. So that's two types of wasting that we see in treatment facilities, and by far most operators are pretty good at making sure that the number one version, the controlled wasting, is done appropriately in all the plants I visited. So that's a good thing.
All right, good advice. Can you talk a little bit about the importance of setting target values as an operator?
Sure. Most all facilities are provided with an operation and maintenance manual, and the engineers who designed and built the facility will have in that booklet or document some type of guidelines on where they design the facility at. What I mean by that is the recommended amount of mixed liquor suspended solids, either in pounds or milligrams per liter. The guidelines for, say, MCRT or SRT, some type of process control strategy, is usually provided in those manuals as well. And it's okay, in my opinion, for operators to use those guidelines to get a feel for how the plant would operate using those, because of the design characteristics or design numbers. But I do want to point out that process control of the facility really comes down to the operator grabbing samples from that plant when it's running its absolute best. Now, I want to be clear that the facility might be running its absolute best, and that means effluent quality, TSS is low, BOD is low, fecal coliform is very low, the turbidity is very, very low, and it's just looking its absolute best. And those numbers that are getting us those results don't always match up with what the guidelines are in those operation manuals. So the O&M manuals are good guidelines and good ways to come up with a strategy, but then the operator's job is to really fine tune that and figure out what's best for that plant. So running the analysis when the facility is working its absolute best, in my opinion, is one of the key components of establishing your process control benchmarks. It's not a very good practice, in my opinion, for someone to just say, well, the book says it should be this, or the book says it should be that, or Joe operator from the other plant down the road says this worked for him, so it must work for me. And I will tell you that I've seen in my career that a lot of plants may have been built by the same engineer and they look exactly the same in another county or another part of the town, but they could operate completely different because of the influent characteristics. So with that said, every plant is different. Every plant has its own unique personality, and it's really the operators that figure out what's best for each individual facility based on its design and influent characteristics. And again, that goes back to the running the plant looking through the windshield rather than looking in the rearview mirror. So that's kind of that idea, Ted.
All right. So, which method of process control is the best?
Well, I would be amiss by telling you that one or the other is best. It would be really probably not good faith for me to tell you what you should be doing. So I do want to offer this to the listeners. um, Whatever method you use, and we'll talk about this in just a second, I'll elaborate in just a second here, but whatever method you're going to use, make sure that you understand what goes into that method, and make sure that it's something that you can do easily and that will work for you, rather than me saying you should be running this test or running that process control method, because every facility is unique, and even the operator's abilities and skills and equipment available is unique. So which method is best is actually the one that gives you the best effluent quality over long periods of time, with minimal cost to the operator and to the utility. And by that I mean minimal cost could be the operator's time that it takes to run some of these analysis. And if there's another method out there that works a little better and doesn't take as much time, you got to kind of consider that into the overall operation, because the operator's time is very valuable. So you want to try to make sure that whatever method you use, it's something simple that is easily understood by the operation staff, and that will work consistently and give a very good effluent on a consistent basis. So as one of the things I want to talk with your listeners about here is that there's a lot of different methods or strategies out there, and I want to list them here, if you don't mind. The first one I want to mention is what we call constant MLSS, and that can be either as mixed liquor suspended solids as milligrams per liter, or as in pounds. And an operator can do either method, and they can calculate the pounds based off of their basin sizes and capacities, or just run by the actual milligram per liter number. And to be honest with you, that's probably one of the most popular, that's probably one of the most common methods of running a treatment plant, is just by knowing what MLSS factor works best for your plant. Um, so with that said, the next method that I've seen a lot being used is what's called solids retention time, and that's also abbreviated SRT. And it's similar in a way to what's known as MCRT, which is mean cell residence time. And both of these parameters, or both of these process control strategies, rely on the operator knowing the basin sizes and figuring the pounds of solids that they have in their aeration system, and then dividing that by the pounds of solids that are wasted out of the system per day, and the pounds of solids that left the facility in the effluent per day. So the bottom denominator part of the equation on SRT or MCRT is essentially the pounds that are leaving the facility per day. And again, that's divided into the pounds of solids inventory that we have in the plant. So it's a little bit more intricate. You know, the operators need to know a little bit more about their facility, like they need to know daily what the effluent TSS is. They would need to know their flow through the plant. They would need to know the waste concentration and how many gallons per day of waste that they actually sent to the, solids handling facilities or wherever their waste sludge goes. So it's a little bit more intricate than just running constant MLSS. So you can kind of see that it's getting a little bit more detailed. Another method is known as constant F to M ratio, which is even a little bit more intricate because it involves the mixed liquor suspended solids represented as MLVSS, which is the mixed liquor volatile suspended solids, which usually involves some sort of muffle furnace to come up with that value. And the MLVSS is calculated out as pounds under aeration, and then it's divided by or divided into rather, the amount of food coming in the plant per day. So this would be the BOD pounds per day coming into the facility. So there's a little bit more work to go along with say running FM ratio, because you need a little bit more data on the influent than most plants actually collect all the time, and it may take a week or more to even get the BOD results for the FM ratio calculation. So there's a limiting factor, or rather a disadvantage, I would say, to running that if you're going to use the straightforward BOD method. A faster version of organic loading is known as COD, which can be done in a matter of just a few hours, and it may be more beneficial to an operator to practice that method for the daily process control using FM ratio rather than waiting for the lab results that may take more than a week. But anyway, in a nutshell, Ted, I just want to share with the listeners that those are some methods of process control that are out there, and I really would be amiss to say that an operator should do one thing or another. Because of the intricacy of those tests and the availability of the equipment and all of that. So I know that was a long answer to that question, but it does involve a little bit of detail. So I hope I didn't bore anybody.
Nothing wrong with a long answer where it's called for. So, Ron, what would be a good metric for? I know that cost is always a factor when you're running a wastewater treatment plant. What's a good metric to use for cost?
A good metric to use for costs, I would say, for the general operations, is something known as pounds of BOD removed per million gallons treated, or the total cost of the utility operation per million gallons treated. And in that cost, we would say something like the cost per week or cost per month of the chemicals that are being used for disinfection, for dewatering, and any kind of chemicals that are used inside the biotreatment train. So the cost per month or cost per year of the chemicals, the electrical cost, which is a big component in a wastewater facility. Usually aeration blowers and aeration methods are usually the biggest cost of the facility as far as electrical consumption goes. So factoring in the chemical cost, the electrical cost, and the personnel, the actual operations staffing personnel, factoring that in versus, or dividing into each million gallons treated or 1,000 gallons treated a time, is usually a good benchmark. And an operator can really, I would say, tighten up the operation overall if they know what those benchmark numbers are first, and then make some tweaks to the treatment process to see if they can improve the overall cost versus million gallons treated. I've had a good example of that when I was younger. We had a facility that I was the manager of, the chief operator, and this facility was just an A1 operation. We had a great staff. The operators were all on the same page. We all got along well, and the plant just ran like a top. It was just wonderful. And in fact, DEP in the state of Florida and the local Environmental Protection Commission in the county used to use my plant as a training ground for new operator, or rather new inspectors, to come visit the facility, look at all my records, look at the effluent quality, look at how we operated the plant. And they used it as like a model. And then they would go out and look at other facilities to do a comparison, which made me very, very proud. One of the factors that I never considered was the cost per million gallons that I treated. I just ran the blowers and I used the chemicals and we did whatever we had to do, but we had a wonderful effluent. So one day we found ourselves under contract operation, and the contract operations company was able to save a lot of money and not really affect the overall effluent quality at all, because they figured out ways to be more efficient with the energy at the facility. The blowers and the electrical consumption of those large motors were, there was ways to combat the high energy demands that I didn't even know about. So I never really paid attention to the electrical consumption and chemical costs as much as I wish I did. And my advice to operators now is to say, get the best effluent quality you can, but then also factor in what it costs to achieve that, because that is also something that, is put back to the ratepayers and the consumers and the folks at your town that are relying on us to do a good job, but also to keep the cost at a minimum. So that's kind of where I would say, Ted, is to use dollars per million gallons treated. You can also factor in other benchmarks if you want. The amount of BOD removed per million gallons, those types of things. But the cost numbers really are the eye opener.
All right. So Ron, we have all this great instrumentation these days. We have continuous online monitoring for things like pH, dissolved oxygen, nutrients, and so forth. Um, it's still important, isn't it, for the operators to use their senses and use their brains in running the plant and not just rely too much on the instrument.
I agree, Ted. I would say that the operators, um, while I want to say that the automation is important, and we're getting very, very automated in all these facilities where there's continuous online instrumentation, and many facilities aren't even staffed like they used to be, where nowadays one plant is monitoring another facility, and they've reduced staff in a lot of utilities, which in a way is good in some cases, but in other ways we find that there's been a lack of attention to some of the um, let's say the important parameters that an operator would actually oversee or monitor or even notice just by being on the plant site. So, the operators are the eyes and ears of the facility, and they're the ones responsible for walking through the plant and looking at the color of the mixed liquor suspended solids and looking at the turbulence in the tank, if it should be turbulent or not be turbulent, looking at the effluent going over the clarifier weirs and making sure that the straggler flock or the pin flock or whatever type of situation is occurring can be caught quickly, or remedies can be made. And those are the type of things that a computer really has not replaced yet with a sensor, because the eyes and ears and even the smell that an operator picks up as they walk through the facility, sometimes they pick up things that you can just tell something is different, or a piece of equipment is not running optimally, and a computer doesn't really know that. A computer might be able to say, or the sensor or the PLC sending the signal to the computer might show that the motor is running, but however, a sprocket could have been could have broken. We could have had a shear pin break on a clarifier drive. We could have had several things happen in the facilities where the motor still shows it's running, but the actual unit is not running. So again, the eyes and ears of the operator are critical. And I'm not against going to continuous reading instrumentation at all, but really relying too much on it can get us into a little bit of trouble, I think, in some cases. So we really want to kind of like buffer that with an actual walkthrough of the operator, measure the sludge blankets in the clarifiers, make the rounds of the facilities, check for vibrations. Operators can feel vibrations of the motors that weren't there yesterday, or hear something a little different that sounds different. The gearbox sounds a little different today than it did yesterday. Those are the types of things that a continuous reading analyzer, as far as I know, can't really tell us everything yet on some of those things. Now there are sensors for motor bearings and things like that, but an operator really needs to still be on site, in my opinion. So we don't really want to just give up the whole operation yet. Again, sensors have failed. We get pH and DO meters that show the same reading all the time because they're getting dirty or ragged up and they're not being maintained. And the computer software might show that the DO is just fine in the facility when actually it's not, because the operator hasn't been there to clean off the probe or to refill the reagents in the units that are doing the automated reading for us. So really, it's a combined system. I mean, we still need to be somewhat hands-on. So I'm a little bit nervous getting too far out in complete automation, but maybe I'm still kind of old school.
Right? All right. So as a final area to cover here, what process control is a category that appears on state exams, and this is something that operators are obviously concerned about. They want to pass their exams and get to that next level of licensing. What would you advise operators about preparing for exams in terms of process control questions?
Yeah, this is something that's been happening a lot over the last several years, and I am a part of the exam committees in the state of Florida, as well as several of my colleagues that I enjoy spending time with and talking about treatment plants and we've found in the last 10 years or so, I would say that operators struggle with the process control portions of these exams. And we think, and I'll speak for several of us on the committees, we've kind of think that the operations has gotten so automated that the operators are losing touch with how to actually control the process with, manually doing it or answering a question on an exam about a process problem, because we're getting so reliant on automation to do things for us. Now, when you take a state exam and you come across a process control type of question, the question is usually in some kind of scenario form. It'll be some worded as maybe a troubleshooting question. It'll say the operator notices this type of foam or that type of flock, or the settling is different today than it was 2 weeks ago. And then the scenario goes a little further to describe some things that the test writer, the person who made this question, is going to be looking at a reference in a manual, usually the operation of wastewater treatment plants volume 1 or volume 2 of California State University, Sacramento, or even the advanced course that they have available, which I think is actually changing as we speak here today. But anyway, the reference manuals are usually part of what this test writer is referring to. So they're going to write this question with a known answer in that manual. The operators that are studying for the test may not read between the lines or infer what the test writer was trying to get at, because the answer comes in different parts of the paragraph. So without having some experience in the process that's being asked about, or in a plant where everything's automated, the operators are kind of losing touch with connecting the dots and being able to answer those questions accurately. Um, and again, we think in some cases, myself and several of my colleagues think that it's the lack of experience that some of the operators have in either running that plant or just even in the overall operation of a facility as an operator. I want to point out that every state's different and every requirement is a little bit different to sit for different types of licenses. But we do find that operators that are coming up through the ranks somewhat quickly, let's say that they've attained their level. Here in Florida, we go from C to B to A, and I know in other states it goes level 1, 2, 3, and 4, or 5 even. But in a lot of cases, operators tend to sit for exams rather quickly to get the licensing kind of out of the way. They might be able to get a raise or a promotion based on this higher license. But they may be sitting for this exam without the experience or the seasoning behind them. So it becomes very frustrating to some folks when they take the test and they fail and they see that they missed many questions out of a category called process control. And they wonder, like, well, what does that really mean? Process control of what? Well, it's a broad statement or a broad category, but really it does mean that the operator taking that exam needs to be familiar with many types of processes, or at least have studied through the manuals and grasped the material on many types of processes, and have an idea of how those things work, so that when a troubleshooting question is posed to them, they can go back on their knowledge of the theory of the operation, which is found in the books. These answers are found in the manuals, by the way. But knowing some basic biochemistry fundamentals like pH and alkalinity and DO and flows and all that type of stuff, and how they relate together, is brought into the overall answering of these questions. And the operators that I would say that struggle the most with those types of questions are ones that really haven't been exposed to some of those parameters yet, or maybe they haven't been in the decision making process yet at their facility. Maybe they're on a shift and they don't really get to be a part of the overall operational decision making. So that's where we see this term process control really throw a lot of operators and examinees into a tailspin, because they're just not quite sure how to answer the questions, or maybe they're not really confident in their own knowledge of those processes. I do like to tell operators in my classes that don't focus on what you think you don't know about something. Focus on what you do know about these processes. Focus on what you do understand about the differences in acids and alkalis and pH and alkalinity and these types of basic fundamentals. Focus on what you do know, and then go through the four questions or rather the four answers that are posed, and cross off the ones that you know can't obviously be correct, and try to whittle it down as best you can. And at the very least, at the very end of this discussion, if you find yourself with two answers that look really close, refer back to what your mind and say, what would the book say? What would the manual say? What does the manual refer me to? What would they say in that book? I don't want to have operators say, this is what we do at my plant, so this must be the right answer. Rather, I would rather have them think, what would the book say? What does the book say the right answer is? And that's where a lot of operators really do find themselves struggling. And we've had people take their top level exams several times in a row and still come up short. And they tell me that the process control category is the one that really is giving them the most trouble. And by the way, that's for drinking water operations and wastewater operations. It's not just one or the other, it's actually both. And the manuals have the material in there. They just really need to study those sections that say process control of the equipment, or the process and controlling the unit process when there's abnormal conditions and observations, anything like that that's in the book that says how to maintain and properly run the plant when there's abnormal conditions, are the areas they really need to focus on. So I hope that helps the listeners with their studies, because that's something that they can get it, they can pass it. It just takes some studying and recognizing some basic fundamentals of process operation. So another long answer.
Well, good advice. I hope that helps some people get a get a better handle on this for their exams. In the minute or so that we've got left, Ron, if someone wanted to access a course at TREEO Center, where would they go to look to learn more?
Oh, that's a great question. I certainly would hope that they'll check us out at www.uftrio, it's uftrio.org. So it's uftreeo.org. Or they can reach me at rtrygar@ufl.edu, and I'd be happy to talk with them or email them, and they can certainly go on our website and check us out and see what we're about, and all the different types of training that we do, and what we're going to be offering online courses coming up here very shortly. So
Oh, good to know about the online courses. Well, Ron, thank you very much for your time. We really appreciate it. We hope we can connect with you on a future TPO podcast.
That would be great. I would enjoy that. I've enjoyed talking with you today, Ted, and I hope the listeners will enjoy this as well, and keep the plants running good, and let me know how things are going out there.
All right, great. Well, let's wrap this up for now. And thank you again, Ron, and hope everybody who listened in has enjoyed this presentation.